All right, guys, so now it's time for the part that we all dread, and that's the math. I know, we don't like math, we don't like calculators, we don't like numbers, but in our field and in our line of work, these are very often common things that we see every day, so we got to get used to them. Math is not supposed to be that difficult or scary or hard. It shouldn't give you nightmares, but this might. All right, so this is the way that we have to process the data. Now that everything is ran on the machine, now that we have data reports, this is what you're seeing on the screen. This is a report. Now, it is not one of your reports. This is a report from a different year, from a different group, from a different run, and quite honestly, probably from a different setting parameter that we chose to run against for this particular batch. And maybe we saw, hey, we can speed this up a little bit faster. We can maybe get something that looks a little bit better if we do this to it. And we made a slight change for this particular year that we ran them together. All right, so if I go up to the top of this report, there's a few things that I need you to look at. The very first one is the sample name. And this is where the identifier is going to be. So for instance, was this a DI water run? Was this a standard? And if so, was it standard 1, 2, 3, 4, 5, or 6? Was this a sample? We ran 5 blood samples. If so, was it sample 1, 2, 3, 4, and 5? Was it a duplicate? Was it the A or the B version? That's how we name these. So that is how you're going to determine which one is which in the report batch that we give you for the analysis piece. So that's going to be the very first thing I want you to focus on. Next up, we want to look at maybe the year. Look, this is 2024. So again, this is not 2024. And, if you were involved as a student in the program and you did blood alcohol in 2024 and you probably did that in person, this is the report that you would have received. But it is not for the majority of you that watch this and that do assignments related to this. So you are going to have your own report that you go by, and it's whatever I present. It is not the 2024 batch. That 2024 batch is separate. It's totally different. So keep in mind what you're seeing on the computer screen right now does not relate to your actual spreadsheet work. These are going to be different numbers, and I'll pull up what you're going to get here in just a few minutes. Okay. All right. So on the screen, this is the report from the instrument, and the proper term for this is a chromatograph. So a chromatograph is the term that's used for this type of graph that I see on the report. And basically what's happening, like we talked about in the lecture video, is that nothing comes through. And then, woohoo, we get something. And then it goes nothing coming through the tunnel of the column. And then sooner or later, pew, whoop, something comes out of that column. So this machine is on the other end and it's counting. It's counting all of those things that are coming through. How many molecules is it counting that's escaping out of the other side? That is what this is all about. So the higher this peak is what we call that. The higher the peak, the more stuff that is present. So we are going to call this a peak. And there's mainly 1, 2, 3, 4, 5 major peaks that I see here very easily. 5 different ones are here. And each one of those peaks is going to come from a component that we have added into that series of standards that we made. So let's keep in mind what was in there. Well, we used acetone as one of the standards, right? We added acetone. We added methanol that I'll abbreviate MEOH. We added ethanol that I'll abbreviate ETOH. We added isopropyl alcohol, so that's IPA. And then we added propanol, so I'm just going to put prop for the internal standard. The prop was the same amount into every single flask. There were no changes at all. We made a master mix. Or not really a mix. We made a master standard, and that standard was diluted down, and then we diluted into each single headspace vial. And the purpose of the propanol was an internal standard. So if you've taken CTC 150, you should know how to handle the internal standards when they show up in the laboratory. And if not, we're going to talk about it again, because I guarantee you probably didn't know or feel really good about the internal standards at that moment. And we'll show you how to process the internal standards here with a set of data. All right, so that propanol, the value should not change. And that value that we are focused on will come from the area column. That is where we're going to be using these numbers, doing something with those numbers. I'm not going to do it all for you, but I'll do enough of it where I think that you'll feel a little bit better about what's to come in the spreadsheet. All right. So I've got ethanol, methanol, ethanol, isopropyl alcohol, and propanol. Those are 5 main peaks. And for this particular group of students on this report, there is 1 and 2 and 3 and 4 and 5. So it looks like there's 5 different components that show up. Normally they go in order of boiling points. And many times the smaller the molecule, the lower the boiling point. Acetone has a tendency to come off first or second, depending on the column. And then methanol follows, then ethanol follows, then rubbing alcohol follows, and then propanol will follow. And propanol will happen on the very tail end. It is one of the largest molecules that is a straight chain molecule. There's no branching, and that boiling point is higher than the rest of them. So just by knowing that, if I didn't know anything out about the chromatogram, I'm going to say this is our last peak. So therefore, that is the propanol one, which is the internal standard. And the reason I'm going to deem that as the propanol one is because this has the highest boiling point of all of those compounds that we analyze. Now, if I was unsure and if I didn't feel really comfortable, what could I do? Well, I could self-check myself. And the way that we do that is we get a propanol, and that propanol is going to be a standard. So I'm going to call this a very clean propanol only standard that we should have injected in the batches and ran them. And that one peak, because there's only one thing in that solution, would show up, and we would probably see that that one peak that would show up for propanol would be around 7.9 minutes. That is what that number on top of each one of those peaks represent. So this is the time that it took in order for that component to travel through the tunnel, aka column, and make its way out the other end before it was counted and detected. And because of that, we have a proper term for that, and that is a retention time. So retention time is T sub R. That is how we abbreviate that. So the retention time for propanol is 7.9 minutes. That's how long it took for propanol to be injected into the machine. That's how long it took from the time of injection through the column and out the other end to be detected. All right, so that's one of the ways that we could just double check. Yeah, okay, 7.9 minutes. Okay, that's for sure going to be propanol for that particular standard that we're looking at. Up next, we've got all of these other things in there. Methanol is in there. Ethanol is in there. Isopropyl alcohol is in there. We can do data on every single one of these. That is not a problem. We can, and we probably will build calibration curves just for the fun of it. But really what we're after is blood alcohol concentration. That's ethanol. Ethanol, are you home? Are you home, ethanol? How crazy did you get tonight? Huh? You hangover? Your head hurts? Your stomach hurts? You upset? That's what you get for staying out all night. Hey, ethanol. All right, so ethanol is going to be a component. That component is going to be injected into the GC system. We saw that. Ethanol is going to take its time and it's going to go through the tunnel, aka column, and it's going to go out the other end of the detector. So we get ethanol that finally arrives. Yay! And then the detector is out there and it's counting how much ethanol is coming through. How much ethanol is coming through? Count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is counting, and the more ethanol, the higher the signal. And again, that signal is also going to relate to the area. That area basically means area under the curve or area under the peak. So the taller the peak, the more area that's underneath that peak, well, the bigger that number is going to be, and the more of that stuff is going to be present. So for this particular lab, for this year, 2024, for that group of people, well, this is what happened, all right? We injected ethanol only because that's the most important piece out of the bunch. That's what blood alcohol concentration is. So we injected ethanol only, and what we discovered is that the ethanol peak was right here, 5.5, all right? So that means that is the most important peak. That's the one that we focus on. That's the one we're going to talk about first. And I think that if we go through the motions of handling that peak, you'll be able to do the same thing for the methanol if it asks for that, and the propanol if it asks for that, and the isopropanol if it asks for that. No big deal. All right. And then again, this here on the very end, this is our, not IPA. Gosh almighty, I'm getting so excited. I don't know what I'm doing anymore. This is our propanol that we have used as an internal standard. All right, so hopefully what we'll see is that this ethanol peak, we built a series of standards. There were a total of 6. And that series of standards went really, really tiny. And then it went more concentrated, more concentrated, more concentrated, more concentrated, more concentrated, until that peak gets bigger and bigger and bigger and bigger and bigger. Propanol, though, was an internal standard. The purpose of the internal standard is to do what? Ding, 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 ding. The internal standard is going to test our auto sampler, because you know what? It injected, not me. It might not be perfect. I know that I am, but that auto sampler's not. So this is a way that we can track to make sure that that internal standard was handled the proper way and that the auto sampler was performing the proper way. This number should not change drastically. That's the thing here, does not drastically change. Now, nothing is perfect. That value will change. And the value that I'm talking about at 7.95 minutes, if I come down here, 7.95 minutes retention time, that area is 53,834. That's the value that I'm talking about. That 53834 will fluctuate. Nothing is in a perfect world. The auto sampler is not perfect. Sample injection is not going to be the same from injection to injection to injection to injection. There are slight differences that begin to happen, and we can take care of those slight differences if we involve an internal standard, because it's checking my auto sampler to make sure it's performing the proper way. And by the time that we do the math, it's going to correct. Because if I get more internal standard, it's probably going to be more sample that was injected. If I get less internal standard, that's probably less sample that was injected. My internal standard was in my samples as I injected them. So they should go hand in hand. So that way I can correct for these slight differences that begin to happen in the auto sampler. So we got to go through the process of how this all math is going to work out. There's tons of numbers and you're like, oh my God, I don't know what to do. Okay, well, there's all kinds of areas on this, absolutely. But for the video's sake, we are going to focus on ethanol only, and that's 5.59, which is right here. And then that's going to be propanol only, which is 7.951, because that's the internal standard. And we're going to be using the areas that are associated with each one of those timestamps on every single standard and every single sample and every single quality control. We got to treat them all the same way. So now You get a hodgepodge of different information on a report, and you can at least focus a little bit on what numbers are going to be the most important. So for this particular group of reports, not yours, but for this particular group of reports, we're going to be looking at the time of 5.593 for ethanol, and we're going to be looking at 7.951 for propanol. Ethanol is what we want to measure and report. Is somebody drunk? The propanol is the internal standard, and that is there to allow me to account for the slight differences that begin to happen in the injection side of the machine. Woo! Okay. So with that said, in the next video, we're going to take this information now, we're going to start dumping it into a spreadsheet. And we're going to walk through the spreadsheet step by step. Now might be a good time to take a break. Get your nerves up. Get your thinking cap on. You'll need them.